Assalamu alaikum, class 12th, subject physics. Today's topic is Lenz's law. By Faraday's laws of electromagnetic induction, we have seen that if a magnetic flux linked with the coil changes, EMF is induced in the coil, as a result of which current flows through the coil. Faraday has performed various experiments in order to demonstrate this electromagnetic induction. Now, but Faraday's law does not tell us the direction in which the induced current flows in the coil. This is provided by Lenz's law. It states that the induced current in a circuit always flows in such a direction that it opposes the change that produces it. So what is Lenz's law? States that the induced current in a circuit always flows in such a direction that it opposes the change that produces it. That means here we will take one of the experiments of Faraday, in which we explain the direction of the induced current. Here this induced current is produced due to the change of magnetic flux. So change here is the magnetic flux. So it, as per the law, current flows in such a direction, it opposes its change. It opposes the very cause that produces it, or it opposes the change that produces it. Change here is the magnetic flux, changing magnetic flux. That means it flows in such a way that it opposes the changing magnetic flux through the primary coil. This is primary coil, this is secondary coil. Now we'll explain what Faraday did. He wound two coils, one named as primary and another as secondary, on the same soft iron core. One coil connected to a battery via key, called this primary. Another coil connected with the galvanometer. When the key is pressed, current flows through the coil. See here, current flows through the coil, but here in clockwise. If we see it from the left side, this is the direction, that means it is current flows in clockwise. See here, this is a coil. If this is the if we take a single turn, for instance, this single turn, remember how you can determine how you can determine the south and north pole, because when current flows through the coil, it around it magnetic field is produced. So definitely the coil has two poles. One will be north and other will be south. How we can determine north and south? See here, this is a coil, a single turn coil. This is the front face. We are seeing the front face. If the current flows in clockwise, that will be just like S. Write S. See here S. Here the end of the S. Here is arrow. This is same as clockwise. And in this side, second end of the S having arrow similar to this. So if current flows in clockwise, that face is south. If current flows in anti-clockwise, see here, this once again the coil, current flows in anti-clockwise direction. Anti, right here N. See here, this is direction of current anti-clockwise. This is the end of this N here. Mark here arrow. The arrow and arrow, these two arrows are in the same direction, and this end of N here, here same its direction. Put here this arrow, its direction and its direction is same. So when it is direction of current is anti-clockwise, the phase will become as north. So clockwise we will get south, and anti-clockwise we will get north. See here from the left, this is clockwise, this will become south, and this will naturally become north. Now, as this key is pressed, current grows from 0 to some maximum value. During this, the magnetic field also increases from 0 to some fixed constant value. That means magnetic field varies. And what happens here? Due to changing magnetic field, so this magnetic field, these are close to each other. Since there is a magnetic field associated with this, which is also changing, this will also associate with the secondary coil, and this changing magnetic flux will induce EMF in this, due to which a current will flow through this coil. Now, as per the Lenz's law, the direction of the induced current is as such it opposes the very change that produces it. Very change that produces change is here the varying magnetic flux, changing magnetic flux. But here, as we have seen, this has become north. This magnetic field will flow. It will flow from this south to north. It will flow from south. So magnetic field will flow from south to north. So there, since current also flows due to induced EMF, there will also be a magnetic field. But the magnetic field produced by the secondary should be in such a direction that it should oppose the magnetic field produced by this, or should oppose this magnetic flux produced by this, which is the cause of this production of induced current in this. As magnetic field flows from left to right here, if it has to oppose this, if this induced current has to oppose this very change in the magnetic flux, then the magnetic field in this secondary coil produced due to the flow of current, induced current, must flow from right to left. right to left. That means then and then only then it will oppose its cause. So it is possible only when we will get this face of the coil as north and this as south, and north will cancel, or we can also say, since magnetic field flows from left to right, here it should flow from right to left so that it may oppose its change. That is why here in this phase, if we see the coil from the left side, here the current should flow in anti-clockwise direction. That means it should become north pole, and that happens here. It becomes north pole and this becomes south pole. So we have explained this direction of the induced EMF. So always when we get when EMF is induced in the circuit, in the secondary circuit, the current flows, induced current flows in such a direction that it always opposes the cause, always opposes the cause that produces it. That is also due to the negative sign which appears in the Faraday's second law. Faraday's second law, E is equal to minus d phi by dt. E is equal to minus d phi by, which we have already derived. E is equal to minus d phi by dt. Negative sign means rate of change of flux. Rate of change of flux. Change in the flux is in such a way, in such a direction that it opposes the very cause. EMF, the induced EMF is in such a direction that it opposes the very cause that produces it, that is because of this minus sign. That's all. Thanks.